screencast on acids and bases. We're going to talk about properties of acids and bases, and then what it means to be a monoprotic versus a polyprotic acid, and then talk about strengths of acids and bases, which are probably not what you think. Okay, so guiding questions to keep in mind. Why are acids and bases important? How do they relate to everyday life? And what are some properties of acids and bases? Why are acids and bases important? They're really everywhere. They have unique properties and they have important environmental effects. Acid rain would be one quick example. But I mean, acids and bases, soap is a base. Coffee is an acid. Soda is an acid. Orange juice is an acid. So they are really everywhere. So let's get down to some basic questions, as in what is an acid and what is a base? The first thing we're going to look at is an acid. And an acid is a compound that forms hydrogen ions in solution, H pluses in solution. Okay, and we'll talk about in a little bit what that actually exists as in water. All right, these are Arrhenius definitions. Okay, so a compound that forms hydrogen ions in solution is an acid. A base is a compound that forms hydroxide ions, that OH negative, in solution. And a good example is this calcium hydroxide forming this calcium ion and the hydroxide ion when I put it in water. Okay, this type of equation should look familiar. Dissolution equations, we've done them in the last 2 units. Okay. Names and formulas for acids. What are some common, if we look at them, oh, there's a spelling error. Hydrochloric acid, HCl, H2CO3, carbonic acid, HC2H3O2, we know that C2H3O2 negative ion as the acetate ion. Connect an H to it, I have acetic acid. Citric acid has the general formula C6H8O7. Okay, so what are some common features of names and acids? Well, they all contain the name acid. And then the formula sometimes begins with H, not always. Most of our examples will, right? So acids, for the most part, have H's in them. So what are some properties of acids? Well, changes colors of acid-base indicators. And again, we're using hydrochloric acid, which as a gas, putting it in solution, forms the hydrogen ion and the chloride ion in solution. Acids have a pH of less than 7. These are good things to put down in the notebook. Hopefully you got the definition of the acid and base for Arrhenius from the first slide. Okay. Acids are electrolytes, meaning they conduct electricity because it forms ions in solution. So those movements of charged particles being the conductor, acids are electrolytes. They taste sour. Lemon is a perfect example of what an acid would taste like. And they react with many metals, as we found out in the last unit with types of reactions, zinc replacing the hydrogen to form zinc chloride and hydrogen gas. And importantly, acids react with bases to form water and a salt. Please keep in mind that when we say salt here, that's a common name for an ionic, you have to bear with me because I don't have my normal stuff, ionic compound. Gosh, that's sad. Okay, so acids react with bases to form water and a salt or an ionic compound. So let's turn the page, or flip the slide, and talk about names and formulas for bases. Okay, if you notice here, I've got sodium hydroxide and calcium hydroxide. Those are the formulas. We know the names from naming ionic compounds. What are some common features of the names and the formulas for most bases? Hopefully you picked up that they're ionic compounds and they contain the hydroxide polyatomic ion. This should have a negative charge on it. because it is an ion. Okay. There is one exception to these bases, and that is ammonia. Ammonia NH3. If I put NH3, ammonia, in water, it is going to form something called an equilibrium, which means that all of the reactants don't react. Okay, so I'm going to have some ammonia and water and some ammonium and hydroxide in the solution. Okay, it doesn't go to completion. It hangs out somewhere half done in that reaction. Okay, what are some of the properties of bases? Well, bases also change the color of acid-base indicators. Things like litmus paper. I always remember that a base turns litmus paper blue. Base, blue. And that's really how I remember it. Okay, bases have a pH greater than 7. They are also electrolytes because we form these ions in solution. If it conducts electricity, if I have movement of charged particles, it is an electrolyte. They taste bitter. They have a slippery feel. Soaps are bases. If you feel them, they feel slippery. And bases react with acids to form water and a salt, more commonly water and an ionic compound. Monoprotic, polyprotic. Hopefully you know mono means one. A monoprotic acid is an acid that contains one ionizable hydrogen, meaning the hydrogen can come apart from the anion part of the acid. Diprotic, di meaning two, is an acid that contains two. For example, sulfuric acid, H2. Both of these H's can go into solution. There is also a triprotic acid. 3, mono, di, tri. 3 ionizable hydrogens. So those 3 hydrogens on this phosphoric acid can go into solution, and I would have a triprotic acid. Okay, strength of acids and bases. This is where the definition is going to differ a little bit from what you may have thought a strong acid was. Definition of a strong acid and a strong base are substances that completely dissociate or ionize in solution. Okay, so they are strong electrolytes because they go fully into those ions. Nitric acid is a strong acid. It goes fully into that hydrogen ion and the nitrate ion. Potassium hydroxide, as a solid, we know because this is a group 1 metal that it is soluble. So if I put potassium hydroxide in water, I'm going to get a potassium ion and a hydroxide ion. They go to completion. Okay? That is the definition of a strong acid. It has nothing to do with the concentration. It doesn't have to do with whether that acid will dissolve your skin. It has nothing to do with that. Whether an acid's going to dissolve your skin or not really has to do more with the concentration of that acid than whether it's a strong acid. Strong acid really just means fully ionized in solution. Okay. On the other hand, or conversely, a weak acid or a weak base doesn't completely dissociate into solution. It's a weak electrolyte. Okay. It only partially ionizes. So if I have the acid HCN, these arrows mean it does not go all the way to the product side. So in solution, I'm going to have the molecule HCN. I will have the H plus ion, and I will have the CN minus 1. Okay, we need to add that we will have the H plus ion in solution. All right, we'll have all 3 of those things in solution. Okay, there are 7 strong acids. I took this list from AP. It was a little different than Dr. Carrier's. Hopefully IB is the same. Hydrochloric, hydrobromic, hydroiodic, nitric, sulfuric, perchloric, and chloric acid are the 7 strong acids that you need to know. Okay, weak acids are basically anything else. Okay, the weak acids would include acetic acid and phosphoric acid. Okay, the 7 strong acids, you need to know what they are, or at least recognize them. There are 7 of them. Strong bases, group 1 and group 2 hydroxides. Okay, so group 1 metals, group 2 metals with the hydroxide, those are the strong bases. There's only one common weak base, and that is ammonia. You should be able to memorize those 7 strong acids, know what the strong bases are, and remember the one weak base. And that brings us to the end of the first screencast.